Hey everyone, and hope you're having a good time in this conference. I would like to welcome you all to Debugging That Bugger, cleanly handling the errors. So first I would like to give a short introduction of myself. Uh, I am a 20-year-old person pursuing a bachelor's in data science from IIT, which is the Indian Institution of Technology, and currently working as an integration engineer at Chatelaine. You can find my social handles of Twitter down there. So have a look at this picture. Relatable, right? So yeah, even if it was relatable for me as well. So the thing is that it's almost impossible to write a bug-free code. But it's, well, you can really work it up and do your best. So to quote an age-old joke among the programmers, writing code accounts for 90% of programming, but debugging that same code accounts for the other 90%. Yeah, I know the math isn't mathing here, but you get the point, right? So since your machine can only do what you want, what you tell it to do, and not what you intend it to do, today I'm going to share with you a few tools and techniques which were really helpful for me while I started debugging, except using just print statement after every line, which is really not optimal. So first, I would like to talk about traceback. I know, I would like to really take it from the very beginning. So traceback is actually, whenever Python runs into an error, it produces a whole lot of information about that error, which can be really overwhelming in the beginning. But yeah, once you really get to know what is going around, you can figure it out, like where the error is and what is exactly going wrong. To give you a very simple example of that, consider this list here. It's a very small list, very basic example, and you can see that the 10th index, you don't really have that many elements in this list. And you will get this sort of error, which, yeah, it was really overwhelming for me in the beginning. I'm like, what the fuck? Sorry. What is going on? Okay, so let's try to break it down. As you can see, in the first two lines show the traceback statement for the most recent call. It shows information related to the file name, the line number, and the module name. The next line is the line where it shows this is the exact line where your error is occurring. And the last line is divided into two parts. The first is the name of the built-in error that Python has run into, and the next is the relevant information about it. Yeah, that error was not deliberate. Okay, so what you can do to work your things around it is the very basic thing you can do is use the try and except statements. In the try statement, you put the code that could potentially have an error, and next statement is the except statement. So whenever Python runs into this whenever Python tries to execute this line, the try statement, if it runs into an error, it will run into the except statement and execute the code which is in that statement. To give you a very simple example again, here is the very basic function in which we have provided a parameter divides by. So this function do nothing else but just divide the number 42 by the number that we have passed into it and returns that value. And here you can see we have tried to divide it, use this function 4 times. And you can see this whole error, the traceback error which you can get. But at the same time, okay, all right. Must be an internet connection problem. Okay, so anyways, what else I had done that is simply that I have wrapped these 4 print statements into a try and except statement. And we would use that by putting these 4 statements into the try and using that except statement to catch the 0 division error and print whatever this error is going to print for us. I know you cannot see the output right now, but maybe let's try it. Okay, no, it's maybe it's the image problem. Okay, so, well, this was about how you can handle your errors, the built-in errors, the Python that shows you. But what is the next thing you can do is raise those exceptions yourself. And by raising those exceptions yourself, you can use it for your advantage, and that can be really helpful for you. All you need to do are three things. All you need are three things. The raise keyword, a call to the exception function, and a string with a helpful error message passed to the exception function. So raising an exception is kind of like a very basic way of saying that stop executing the program that you're doing and simply move on to raising your exception. Okay? So as you can see, I have used this raise exception. This is the error message by entering it into the interactive shell, and you can see that it gives us that same traceback error message. Pretty simple, right? But that's the thing. Raising exception is like raising a error, raising a very basic error. And what you don't want to do is you don't want your program to crash. That's the whole point why we use that try except statement, because we don't want our program to crash. So you have to make sure to use the try and except statement covering our raise statements so our program doesn't crash. Because that's exactly what try and except doing is, right? It executes your program. If it's run into an error, it cleanly executes it, print whatever you have told it if it runs into an error, and continue executing the rest of the program like an error never happened. So yes, you can use these raise exceptions very easily, but still there are a few things that you should always keep in mind while using raise exception. The first is that you should not use a bare except statement. And what I mean by that is have a look at this program. It's a very, very simple, snippet of code where I've tried to define a function to upload a proof of address for a doc. Imagine you have an app where you want the user to upload some proof of documentation. So you have provided them with this function. In the try statement, you have tried to send the notification about the upload status of that document. And in the accept statement, as you can see, we have used a bare accept statement. We have not specified what kind of error we could run into and what kind of error we might deal with. And we have simply printed a file upload failed message. So this can be really, really mind-bending, honestly. It can be really stressful because imagine we have a user who is consistently trying to upload a file in that app, and no matter whatever possible solution he tries to solve that problem, he is getting that same message, file upload fail, even if he tried to change the format of that file, or if he's trying to change the size of that file or anything. So instead of catching all exceptions with bare except, we should catch only specific exceptions that you might run into. I know it's really difficult to think about all sorts of possibilities, but even if up to some extent you can think about those possibilities, then you can save yourself a lot of time. Because the bare except statement catches all sorts of exceptions that you can run into. The next is that you should not raise or catch generic exception function. So to understand this, I would like to give a basic knowledge about Python is that Python has a hierarchical structure when it comes to the exception class. At the very top, we have the base exception class. So it is the exception for all the built-in exceptions that are in the Python. It provides common methods and practices for all the subclasses that it follows. And it's further divided into exception and generator exit. The exception class, which is a subclass of the base exception, is the base class for all the built-in exceptions that are in it, which is further divided into standard error and keyboard interrupt and a lot more other things. So what we really need to take care of is that exception class, which is the subclass of the base exception. To give you an example of what kind of problem we face is that due to that hierarchical structure that Python follows, it usually tends to hide those bugs that you run into. So if you look at this example, which is a demo bad catch function, Here we have tried to raise an exception, and this is the exception that we accept to handle. And in the accept statement, we have passed a value error as an error. The problem is that value error is a built-in class of Python, and it comes as a subclass of exception class. Due to this, if we have tried to catch the value error, it won't catch that generic exception function. And since we have tried to catch this particular error in the try statement, it won't catch it. And it can be a big problem for you, because then you're trying to figure out that what is going wrong with your code, even if you have tried to handle your exceptions carefully. The other example is this example. Like, trust me, there are a lot of ways to write bad code, but this is the worst. So you should really never raise or catch generic exceptions, because here we have tried to raise that generic exception. Consider this raise value error. This represents our hidden bug that we do not intend to catch. But since we have used an exception in the accept statement, it will catch this value error because it's a subclass. So it catches all the classes, all the errors that are a subclass of the exception function. And even though we didn't intend to catch it, we might run into these kinds of error. And we can also run into system exits and keyboard interrupt kind of errors, which are very systematic errors and not even related to our code, but it can be a big problem for us. So this was all about handling the errors, reading those errors, and what you can do to avoid those errors or even use them to your advantages. But are there any ways to avoid those errors altogether? Are there any ways that you can avoid them completely or maybe even up to some extent? Well, what if I told you that you can avoid those errors? But yeah, only up to some extent. So let's talk about assertions. So assertion is a sanity check that makes sure that your code isn't doing something obviously wrong. Which means that if your code fails, if your sanity check fails, then your assertion error exception should be raised, because that's the whole point of it. If it's like a checkpoint for our code to see that you're not doing something very obviously wrong. The basic syntax of it is the assert, then followed by a condition that you have to check, followed by the string you want to display when your condition is false. So, of course, again, my presentation can never be complete without examples. So here it is. We have this ages list, and we have used it to sort the ages list. And you can see that our list is sorted here. And then we have used the assert statement to assert the condition that the first element is less than or equal to the last element of it, just to check if the sort function have worked properly or even not. So as you can see, it's correct. The sort function has worked properly, and this is exactly why the assert statement will do nothing. We won't get any output because it's doing everything fine. So that's the thing. If your code is bug-free, then that sanity check helps you realize that, okay, things are fine, and you don't have to worry about anything. Meanwhile, let's consider this. We have changed the sort function with the reverse function on purpose to see how it will affect our things. And surely enough, we will get this sort of error. So this was about assertion. And lastly, I would talk about I would like to talk about a few things that you should keep in mind while using the assert, is that you should never use try and accept statement around your assertion statements. And why is that? Because unlike exceptions, you really want your assertion statements to give you an error, to tell you that you are doing something wrong. So if it fails, then your program should crash, because that's the whole point of using an assert statement. It can save you tons of time, and by failing fast like this, you can really figure out what's the cause between the bug and the actual reason between the bug. And in this way, it can save you a lot of time. The next thing is that there should be no assertion error in your finished program. So assertion errors are used for programmer errors. They should be used while your program is still under development, and a user should not see any assertion errors, because these are the sanity checks that you are using for yourself to have checkpoints at every point to see if you are not doing something wrong. The last thing is you should not replace your exceptions with assert statements. And again, the reason is kind of the same here, but the other reason is that user can really turn off those assertions. And yeah, it's possible. Like whenever you try to run your script in the interactive shell, if you use this /o, the /o while running your script, it enters the Python into an optimized mode, which ignores your assert statements, and then there is no point in using it altogether. So the last thing that I really want to talk about is the Python CLI debugger. So it is the command line debugger of Python, which you can use completely. You can completely run it on the interactive shell, so you do not have to depend upon a GUI-based server to debug your program. You can debug using the CLI debugger, using the PBD module, which is a built-in module of Python. And yes, this is the major advantage of it. It runs entirely on the command line, so you don't have to depend upon a GUI-based shell. So it can do tons of things, but there are particularly two of the things I would like to talk about, like setting breakpoints and stepping through code, and a lot more. So while using the PBD module, all you have to do is import it at the beginning of your code and run it in the interactive shell using this syntax. So how you can set a breakpoint? Again, you have to start your debugger using the import PBD module, and then you have to use pbd.setTrace. So wherever you use this setTrace, it sets a breakpoint on the line below where you have used this. As you can see, with the help of an example, that we have imported PBD, defined a very basic function for addition so that it returns our answer. Then we have used this PBD trace here. So our breakpoint will start from the X statement where we have tried to input our first number. And as you can see, I have deliberately made an error in this program. So since we have inputted strings and used additions in them, we will not get a sum. So given we have used pbd.setTrace, our breakpoint is X line where we have tried to input our string into the X. So this is where we should get our traceback, the first line where we should see an error in our traceback. And surely enough, this is the error we can see. So after the angle bracket, it shows us the directory of it, the line which we are having the error, the module, and in the next line, surely enough, you can see that this is our breakpoint. This is where the error have begun to happen. So next thing I'm going to talk about is stepping through your code. You can simply use N, which is short for next, U for up, D for down, and P for print. And you can very easily navigate through your entire code in the interactive shell itself. So as you can see, another example for that is I've tried to import PBD, set A for 20, B for 10. Really a very simple program, just an interactive program. And as you can see here in the output, that I have started a CLI debugger using this syntax, which I told you about previously, and using the end statements everywhere to jump onto the next line. And you can see that this is how easily you can progress in your code while using the CLI debugger. So that's the thing. So that was all I wanted to talk about when it came to exception handling. And these are few things that you can do to avoid errors or handle your errors. So whenever somebody asks you what you can do to debug your code, you don't have to say that. The best I can do is print statement. And thank you.
Thank you, Priyanshi. We have two questions. There's one more. They're not upvoted, so I'm just going to read them in the order of in the incoming order. So first one is, can you give a real-life example where you have created better code by using try except?
Well, it's hard to think about it like that way, but
okay, never mind. It's like probably from like in your actual experience, some example. But if not, never mind it. So the next one is how to manage high number of exceptions.
okay. So yeah, okay. So I know it's unlikely to have a lot of exceptions, and it can be really difficult to pinpoint each and every error that you run into. But what you can do is, if not all the errors, that you can use a combination of these things. Like at first you try to use the try and except statement, but at the same time you're using an assert statement for your sanity check, and in this way you can handle a lot more exceptions rather than dealing with them individually altogether.
Okay, and there is one more. It says using try except is useful, but in some case can be very verbose. Do you think that it's better to use the general except, or is it always considered a bad practice?
Well, yeah, I would definitely say it is not the best practice that you should do. As I've explained already before, that using a generic exception can lead to a lot of problem because of that hierarchical structure. So, yeah, as you could see in my example, where we try to use a value error, where we try to raise value errors and exception together, and then in the except statement we tried to catch only the exception function, and exactly due to that reason the value error was the exception that we were not even expecting to occur, but since it's a subclass of exception function, it was caught in our except statement, and it can create a whole lot of confusion when you are not really sure what you're doing with your code. So yeah, it's considered bad practice, honestly.
Okay, thank you very much. It was a great presentation.